Section 14.1, iterated integrals and area in the plane. Let's check the first example, which is, you see, find the integral or evaluate the integral from 0 to x plus 4y to the y, to the dy. So we're going to do the integral for the y. So here is the first example. We're going to do the integral from 0 to x plus 4y dy. That's mean we're going to do the integral with respect to the y. So x is a constant. So if you want to do it like this way, which is okay, because you're going to do the integral for x dy plus the integral from 0 to the x to the 4y dy. That means this one, we're going to do the integral for y. So x is a constant. So this is the x. It's going to be y plus, I'm doing the integral. This is the basic method from 0 to the x. 4 now is a constant. And here's y dy. And then we're going to do, here is x. The integral for dy is going to be y from 0 to the x plus 4. The integral for y is going to be y squared over 2. And from 0 to the x. And this one is going to be x. We're going to plug in now x minus 0. And here is going to be plus. Here is the 4. Yeah, you can simplify it. 2 with the 4, so it's going to be 2y squared. It's going to be the same thing. 2 on the plug-in, this one is going to be x squared plus 0. That means this one is going to be x times x squared plus 2 times x squared. And the result is going to be 3x squared, because we're going to add these together. Let's check. This is, you see, I'm doing all these steps, but you don't have to do these steps. You're just going to do the integral for x, but with respect to the y. So you can do just x, y. And from 0 to the x plus the integral for y, for y is going to be 4y squared over 2, and from 0 to the x. Then this one is going to be x, plug in the y, which is x minus 0, plus simplify these is 2, and plug in the x is going to be, because here is 2, which is outside, plug in the x, it's going to be x squared minus plug in the 0, 0 squared. So it's going to be x squared plus 2x squared, and it's going to be 3x squared. So it's up to you. Both is going to be right. This is just a shortcut. And this one is going to be 3x squared. Here we go. We got the 3x squared. That's right. Let's go to example 2. We're going to do exactly the same thing. So we're going to do an integral from x to the x to the power 4 y over x. Now we're going to do the integral to the y. Yes, to the y, not to the x. So to do the integral to the y, this one is mean 1 over x is a constant. That means the integral from x to the power 4 y dy, which is equal 1 over x And here is going to be y squared over 2 from x to the x squared. Now let's keep going. Now just a plug in. So this one is going to be 1 over x. Gonna plug in the x squared here. So be careful. It's x squared and instead of each y. So this one is going to be, oh, sorry, this is x to the power 4. So it's gonna be x to the power 4 for each y. That means squared divided by 2. And minus, we're gonna plug in the x. This one is going to be x squared divided by 2. And keep going. Here is 1 over x. Simplify this part. Is going to be x to the power 8 over 2 minus x squared over 2. Now distribute 1 over x. So this one is going to be x to the power 7 over 2 minus x over 2. We can write down in a simple form. I'm going to take 1 over 2 as a common. So it's going to be x to the power 7 minus x. That's it. So here's where we get another check mark. It's just like the same method you're using to find the integral, but again, we're going to find the integral to the y. So 1 over x is going to be a constant. You can take it out and do the integral for the y. Example 3, the integral from 0 to square root of 7 minus x squared, x to the power 6y dy. We're going to do the integral to the y, so x is a constant. You can just take the x out as a constant and work with the y. So I don't think so. This is hard. Let's check that. This is the integral from example 3. The integral from 0 to the square root of 7 minus x squared. And here x to the power 6 y dy. So x to the power 6 is a constant. That means this one is going to be equal x to the power 6, the integral from 0 to 7 minus x squared y dy. And this one is going to be equal x to the power 6. Let's do the integral for the y. So it's going to be y squared over 2, and from 0 to the square root of 7 minus x squared. Now this one, we done it from the integral, we just have to plug in the numbers. So this one is going to be equal, here's x to the 6. Now we're gonna plug in square root of 7 minus x squared here. So it's going to be square root of 7 minus x squared divided by 2 minus 0 squared divided by 2. This is cancelled at 0. So the left here is going to be x to the power 6. And this is squared, so it's going to be 7 minus x squared divided by 2. Now let's simplify it more. So it's going to be 7 x to the power 6 minus multiply. You're going to add the exponents. So x to the power 8 divided by 2. That's it for this example. You can simplify it more, so just keep it like this. Let's check that. So it's going to be on the top 7 x to the power 6 and minus x squared, sorry, x to the power 8 and over 2. There we go. Let's check that. There we go. We got it right. So example 4, the integral from x cubed to square root of x squared plus 4y cubed dy. So we're going to do the integral to the y. So this is a constant. So to do the integral here, I'm just going to say it's x squared y plus, to do the integral here with respect to the y, is going to be 4 y to the power 4 divided by 4. And this is from x cubed to square root of x. This is the shortcut. I'm going to do the integral right away. This is a constant. To do the integral, that means there is a 1 here. The integral for 1 is going to be, with respect to the y, is going to be y. Now this is a y, so the integral is going to be 4y to the power 4 divided by 4. Now we're just going to plug in now. And this is the important step. Cancel this one with this one. So it's going to be equal x squared y plus y to the power 4. And so from x cubed to square root of x. Let's plug in the x square root of x. So it's going to be x squared times square root of x plus, here is going to be square root of x to the power 4 minus, plug in x cubed, so it's going to be x squared times x cubed plus x cubed to the power 4. So this one is going to be, this is x squared times x to the 1 over 2. So we're going to add the exponents. 2 plus half is going to be 5 over 2. So let's add down here so I can know. Plus, this is going to be x squared. Because here is the exponent 2, 4 divided by 2, the radical 2, 4 divided by 2 is going to be 2. And everything is minus here. This one is going to be x squared times x cubed plus x cubed to the power 4. Just doing extra steps. So combine these together. When you multiply 2 base with the with different exponents, you're going to add the exponents. So it's going to be x to the power 5 over 2 plus x squared minus, here is going to be x to the power 5 plus x 12. Then the last step, we're just going to say this is x 5 over 2 plus x squared. Let's see here. Yeah. It's supposed to be minus here. No, it's plus. So it could be minus x to the power 5 minus x 12. Just going to distribute this sign. That's it for this one. So this one is going to be equal. Do the integral here with respect to the x. So it's going to be x cubed over 3 plus y to the power 8 x. And the boundary is going to be from negative square root of 4 minus y to the power 8 to the positive 4 minus y to the power 8. Now we're going to plug in these. That's the important thing. Plug in this one here and here. So it's going to be, here is the first one. I can know This one is going to be square root of 4 minus y to the power 8 cube over 3 plus, plug in here with the x. So it's going to be y to the power 8, parentheses, square root. You don't have to write down the parentheses. Four minus y to the power 8 minus, plug in the negative one now here. So it's negative square root of 4 minus y8 cubed over 3 and plus y8, because here is negative, so I'm going to put the parentheses 4 minus y8. Now next step, this one is going to be, this one is a cubed, so I'm going to write down this side is 4 minus y to the 8 to the 3 over 2. Divide by 3. Plus, here, just keep it like the same. And here is going to be square root of 4 minus y to the 8. Minus. Now let's work on the second one. This one is a cubed. So everything cubed, that's mean negative times negative times negative. So it's going to be negative. So I'm going to take the negative out and write down the left here is negative 4 minus y to the 8 to the 3 over 2, and everything divided by 3. Plus, I'm going to keep this one, y8 square root of negative. I'm going to take the negative out, so it's going to be minus here. So minus y to the power 8 square root of 4 minus y to the power 8. Now it's easier to work on. Negative, negative is going to be positive. So I'm going to distribute the sign. So this one is going to be equal. Here is going to be 4 minus y to the power 8, 3 over 2, divided by 3, plus y to the power 8, square root of 4 minus y to the power 8, plus, because negative times negative positive, 4 minus y to the power 8 to the 3 over 2, divided by 3 is going to be plus, again, because negative times negative positive, y to the power 8 square root of 4 minus y to the power 8. You don't have to put the bracket anymore. Now, last step, we're just going to combine, because this one similar to this one. So this one is going to be equal to 4 minus y to the 8 and the power 3 over 2 divided by 3 plus also 2 y to the power 8 square root of 4 minus y to the power 8. Let's see if we can simplify it more. If you look to this one, this is half. 4 minus 8 and 2 is a common. So let's take the 2.5 out and see what's the left. 2, I'm just simplifying. I think if you write down this is going to be right. 4 minus y to the 8. And let's see what's the left. From this one is going to be this parentheses with 1, exponent 1 over 3. So it's going to be 4 minus y to the power 8 over 3. Plus, take the 2 out as a common, and half, 4 minus to the power half. The left here is y to the power 8. Let's keep going. You can add these together. So here is 2 square root of 4y to the power 8. And here, this one is going to be 3 over 3, because we found the common denominator here. A plus, I'm going to multiply by 3 and divide by 3. That's mean we can add these together. So it's going to be only 4 minus 2, sorry, 4 plus 2 y to the power 8. Let's write down here. 2 square root of 4 minus y to the power 8. And here is going to be 4 minus y to the power 8 plus 3 y to the power 8, and everything divided by 3. And this one is going to be equal to square root of 4 minus y to the power 8. And the left here is going to be it's going to be 4 plus 2y to the power 8 divided by 3. Let's keep going. Can we simplify it more? To the power 8. Let's take the 2 from here as a common. So, and the 3 out. So this one is going to be 2 times 2 is going to be 4. That means 4 over 3. And here's square root of 4 minus y to the power 8. And the left here is going to be 2 plus y to the power 8. That's it. We can't keep going. But I think if you plug in here, this part is going to be right. But I just want to simplify it more. It's up to you. If you just learn how to simplify, it's fine. So let's check this one. You can try to plug in this one and check if it's right. If you want to keep doing the math until you simplify it and stop, you can't simplify it anymore here. So that's it. But I think if you plug in this side, it's going to be right. So let's check how we're going to work on example 6. It's the integral from y to pi over 2 sine cubed x cosine y with respect to the dx. Dx, now that's mean the y is a constant. So you can take the constant out. So this one is going to be equal cosine y, the integral from y to pi over 2 sine cubed x dx. Let's check how we're going to solve this one. Now we need to find the integral for sine cubed. Remember, sine to any power. I'm going to write down this as this one equal cosine y, the integral from y, not 0, to pi over 2. I'm going to say this is sine square x sine x dx. Now we're going to do the integral. Sine squared x, it's 1 minus cosine. So this one is going to be equal cosine y, and the integral from y to pi over 2, 1 minus cosine square x, and here is sine x dx. Now let's let u equal cosine x. So du is going to be negative sine x dx. I need to find the dx, so I can substitute u on dx. U on dx here. So divide both sides by sine, or by negative sine x. So dx in this case is going to be equal du divided by negative sine x. So now we're going to substitute u and substitute dx. Where? Here. That means this one is going to be equal cosine y, and here is the border from y to pi over 2, 1 minus u squared, sine, keep the sign, dx is going to be du divided by negative sine x. Now cancel the sign with the sign. Take the negative sign out. So it's going to be negative cosine y. So this negative sign is going to go out here. And the integral from y to the pi over 2 is going to be 1 minus u squared du. Now this is easier to work on. Find the integral for this one. So it's going to be, this one is equal negative cosine y. And this one is going to be u minus u cubed over 3. And from y to pi over 2. Then let's bring back the u, which is cosine. So that means this one is going to be equal negative cosine y. And here is cosine x minus cosine cubed x over 3. And from y to the pi over 2. Then plug in these. Let's open negative cosine y. And here, the top part is going to be plug in pi over 2 here and here. So it's going to be cosine pi over 2 minus cosine cubed pi over 2 over 3 minus, plug in the y, so it's going to be cosine y minus cosine cubed to the y over 3. So now this one is going to be equal negative cosine y. Cosine pi over 2 is 0. So this is 0 and this one is 0. So everything here is going to be 0 minus 0. Minus this one, we're going to keep it as a negative cosine plus sine. Plus cosine cubed y over 3. Now, distribute this cosine, so it's going to be cosine squared y minus cosine to the power 4 y over 3. I think we can't simplify it anymore, so this one is going to be the solution. Let's check cosine squared. It's supposed to be cosine. I'm gonna write down cosine squared. Yeah, cosine squared to the y and minus cosine to the power 4 out here. And y and everything over 3. There we go, we got it right. So let's find the double integral for this one. So first of all, what I'm going to do, I'm going to find the integral with respect to the x. Sorry, for the y. So find the integral here, only for this one. That means the integral from 0 to 2 is going to be, the integral for this one with respect to the y is going to be xy plus y squared divided by 2, and the border from 0 to 4, and here is dx. I'm done from the first integral. Now I need to plug in these. So this one is going to be equal the integral from 0 to 2. Plug in the 4 here in the x in the y. So it's going to be 4x plus, plug in the 4 here. We need to put 2 parentheses. So, okay. And plug in the 4 here, so it's going to be 16 divided by 2, it's going to be 8. This is the first one. Minus, plug in the 0, so this is 0 minus 0. And everything is dx. So this one is going to be the integral from 0 to 2 just for the 4x plus 8 dx. Then this one is going to be 4x squared divided by 2 plus 8x, and the border is from 0 to 2. And this one is going to be equal, plug in the 2. So this is 2x squared, that means it's going to be 2, because you're going to cancel these. So it's going to be 2 times 2 squared plus 8 times 2 minus, plug in the 0, which is 0 plus 0. And then the result is going to be 4 times 2. It's going to be 8 plus 16. It's going to be 24. We're done from this example. We're just going to plug in 2, 4. The same thing with example 8. You're going to do the double integral and also example 9, but just different type of functions. Let's do the integral for everything inside. That's mean here to the y. So this one is going to be equal the integral from -1 to 1. The integral for this one with respect to the y is going to be x squared y minus y cubed over 3. And the border from -2 to 2. And the left is going to be here dx. Then let's plug in the 2. So this one is going to be equal. Let's do it here. No, it's not going to fit here. So it's going to be equal the integral from -1 to 1. Plug in the 2, so it's going to be 4y. We're going to plug in the 2 and the y. So it's going to be 2x squared minus, plug in the 2 here, so it's going to be 8 over 3 and everything minus. Plug in -2 here, it's going to be -x squared, -2x squared minus, plug in -2 here is going to be -8. So here's going to be -8 over 3. And here is dx. Let's simplify this one. Integral from -1 to 1. This side is going to be 2x squared minus 8 over 3. I'm going to distribute right away so I can combine the log terms. So this one is going to be plus 2x squared. And here is a plus. With this one is going to be minus. Let's check that. Yeah, this is going to be minus. So now we're going to combine. So integral from -1 to 1 is going to be 4x squared. Negative is going to be -16 over 3. And everything now to the x. So let's move on. So now we're going to do the integral to the x. So this one is going to be, we can do it here. The integral from, let's do the integral right away. So it's going to be 4x cubed over 3 minus 16 over 3 x. I'm going to write down 16x over 3. And the border from -1 to 1. Now let's plug in. So this one is going to be equal. Plug in the 1. So it's going to be 4 times 1 cubed over 3 minus 16 times 1 over 3 minus, plug in -1 is going to be -4. Let's write down first. -1 cubed over 3 minus 16 times -1 over 3. And this one is going to be 4 over 3 minus 16 over 3 minus, on the other side is going to be -4 over 3 plus 16 over 3. Because negative times negative positive. Now this one is going to be 4 over 3 minus 16 over 3 plus 4 over 3 minus 16 over 3. Then negative, negative, positive, positive, but all the common is 3. So this one is going to be 8 over 3 minus 32 over 3, which is equal negative 24 over 3, which is equal negative 8. So we're just going to plug in. I combine this one, the negative sign with the negative sign, and the positive with the positive. So we're just going to say negative 8. That's it for example 8. There we go. So let's check this example. I'm going to do the same thing. So I'm going to do the integral to the x first. Because x, then we're going to do the integral for the y. So this one is going to be equal the integral from 1 to 2 is going to be do the integral for the x. So it's going to be x cubed over 3 minus 2 y squared x, and it's from 0 to 4. And here is the dy. The next step, we're going to plug in the 4 and the 0. So this one is going to be the integral from 1 to 2, plug in the 4. So it's going to be 4 cubed over 3 minus 2. Yeah, plug in the 4 and the x. Minus 2 y squared times 4 minus, plug in the 0, which is 0 minus 0. And everything here is dy. And this is cancelled. That means it's the same thing, the integral from 1 to 2 for 64 over 3 minus 8 y squared. 4 cubed is 64 to the y. Let's check how we're going to keep going. Let's keep going. Now we're going to do the integral with respect to the y. So this one is going to be equal 64y over 3 minus 8 y cubed over 3, and from 1 to 2. So now we're just going to plug in 2, then plug in the 1. So plug in the 2 is going to be 64 times 2 divided by 3 minus 8 times 2 cubed over 3 minus, plug in the 1, which is 64 times 1 over 3 minus 8 times 1 cubed over 3. Yes, that's right. 64 times 2 is going to be 128 over 3 minus 2 cubed, which is 8, times 8 is going to be 64 over 3 minus 64 over 3, and it's going to be plus, because negative times negative positive, 8 over 3. Now we're just going to combine 64 minus 64, negative 64 minus negative 64 is going to be negative 28. That means this one cancel here because we have the same denominator. That means the result is going to be 8 over 3. This is for example 9. So we're going to type 8 divided by 3. Here we go. Let's check how we're going to work with this example. example 10. The first thing, we're going to do the integral to the y. So this one is going to be equal. The integral to the y, e to the negative x, 2e to the negative x is a constant. That means is going to be the integral from 3 to the 5. And here is the constant. The integral for the y is going to be y squared over 2. And the border is from 1 to the square root of x. And here is the dx. So this is a constant. Talking about just the first integral. Plug in this one. So this one is going to be equal the integral from 3 to the 5 to e to the negative x. This one is going to be square root of x squared divided by 2 minus 1 squared divided by 2 dx. And this one is going to be equal the integral from 3 to the 5 to e to the negative x. And this one is going to be x over 2 minus 1 over 2 dx. We can simplify this one. So it's going to be the integral from 3 to the 5, 3 to 5, 2 e to the x. I'm going to take 1 over 2 as a common. The left is going to be x minus 1 and everything dx. So now I can cancel this one with this one. That means the left is going to be integral from 3 to the 5 e to the x minus 1 dx. In this case, thank you. So now we're going to do the integral by parts because we have e to the negative x and x minus 1. So let's check here. We're going to let the u, which is, this is easy to find the derivative. So u is going to be x minus 1. That means du is going to be dx. And dv is going to be e to the negative x. That means the integral for this one is negative e to the negative x. So the integral for this one is going to be uv minus the integral of v du. So it means this is equal u, which is x minus 1, times v, which is e, negative e to the negative x, minus the integral of v, which is negative e, negative x, du, which is dx. I'm gonna just put the border here because we do the integral here. And let's keep going, find the integral for this one. That means this one is going to be equal. Distribute. So it's going to be negative x e to the negative x plus e to the negative x. Negative, take the negative out, so it's going to be plus. The integral for e to the negative x is going to be e to the negative x. And here is the border from, it's going to be negative. Because the derivative on the top is negative, it's already here. So we don't have to take the negative out. So we're going to keep this one as a negative from 3 to 5. Cancel this one with this one. That means it's the integral is going to be just this function from 3 to the 5. And this one is going to be plug in the 5. So it's going to be negative 5e to the negative 5 minus negative 3 e to the negative 3. And this one is going to be negative 5 e to the negative 5 plus 3e to the negative 3. I think that's it. We can't move on, and you can simplify it. So for 10 is going to be negative 5, just type e to the negative 5, and plus 3 e to the negative 3. Here we go. Yep. So dy inside, that's mean the first integral is going to be for respect to the y. So I'm going to put the y coordinates, which is from 0 to the 5. And then the outside is for the x. So the border is going to be from 0 to the 9, from 0 to 9. It's a rectangle. Again, we can find the area by just saying length times width, which is 9 times 5 is going to be 45. But let's check how we're going to find the derivative by using the integral. So 11, we're just going to do the integral from 0 to 9, and the integral from 0 to 5 dy dx. So I'm going to do the integral first to the y. So this one is going to be the integral from 0 to 9. And to do the integral for the y is going to be just y from 0 to 5 dx. And this one is going to be plug in from 0 to 9, plug in the 5. So it's going to be just 5 dx, because 5 minus 0. Then the integral for this one is going to be 5x and from 0 to 9. So it's going to be 9, 5 times 9 minus 0. And then it's going to be 45. That's it for this example. So that's what they ask you to do. So let's check example 12. First of all, we need to write down the border here, the integral inside to the y. And I already know the y equal 4 minus, that's mean to the y here, from this point to the curve here. If you take in the rectangles here, the y here is going down with respect to this curve, which is y equal 4 minus x squared, the parabola. It's parabola up. So this one is the same thing if negative x squared plus 4. It's parabola reflect over x-axis and shifted up 4 units. So now this equation is going to be here as a y. So the inside integral is going to be from 0 to the y, which is 4 minus x squared. Because my integral is going to be dy. Then that's mean y equal 4 minus x squared, and y here is 0. Now let's find the outside border with respect to the x. Because I already know y equal 4 minus x squared. Now if you look to the x, when we do rectangles here, and the rectangles is going smaller and smaller. So let's see, this is the first one. And then we're going to do the second one. and keep going. The third one, keep going smaller. So the X is going to this point until this point. That means the outside border is going to be from 0 to 2. Now let's work on this one to find the area for this. So this one is going to be equal the integral from 0 to 2. I'm going to find the integral here, so it's going to be y, and from 0 to 4 minus x squared dx. Now plug in 4 minus x squared, so it's going to be the integral from 0 to 2, 4 minus x squared minus 0 to the x, which is equal the integral from 0 to 2, just 4 minus x squared dx. Now let's find the integral with respect to the x. So it's going to be 4x minus x cubed over 3 from 0 to 2. And this one is going to be equal. Plug in 2. So it's going to be 4 times 2 minus 2 cubed over 3 minus, plug in the 0, is going to be 0 minus 0. So this one is 0. That means this one is going to be 8 minus 8 over 3, which is equal 24 over 3 minus 8 over 3. I'm just finding the common denominator here. Now 24 minus 8, so it's going to be 16 over 3. That's it. Here, how I did this one, you're going to say 8 over 1 and times the 3 times the 3 is going to be 24 over 3. Now I have the same denominator. 24 minus 8 is going to be 16 over 3. So we're just going to type here 16 over 3. 16 divided by 3. But you have to type the border here. This one is 2. And this one is 4 minus x squared. That's it for this one. So example 13, we have two curves here, and we need to find the border. Our integral dy dx, that means y is inside. So here, inside is going to be from this y to the 4x. It's already they're telling you the lower boundary from x 3 over 2, so it's going to be until 4x. But let's check. What about the x? The outside boundary is going to be from 0 to which number? So let's figure out. So y equal y, that means if you want to do a simple graph, just a simple graph, let's check first of all the x point. Which one is going to be the x? Y equal y, that means I can say y equal y. That means x to the 3 over 2 is going to be equal 4x. Then move the 4x to this side, so x 3 over 2 minus 4x is going to be equal 0. Then let's factor out the x. The left is x to the half minus 4 equal 0. That means x equals 0. This is the first boundary for the x. And square root, let's do it the square root. of x minus 4 equals 0. That means square root of x equals 4. Square both sides, so x is going to be 16. That means here is going to be 16. So here is the boundary for the x. Now let's check. We need to find the y. That means the first graph, we're going to meet on certain point here with the x equals 16. But how much the y? The y, if you plug in 16 here, so 4 times 16 is going to be 64. 16 to the 3 over 2 also is going to be 64. So in this case, y is going to be equal for the first one, 16 to 3 over 2, which is equal 64. And y equal, the second one is 4 times 16, which is also equal 64. That means both these graphs meet at the point 64, which is here. So let's say this is the first graph because it's a curve for the 4x, like this. And let's say this is y equal 4x. And the second one is going to be like this. This is y equal x 3 over 2. Now we're going to work on taking rectangles here and go ahead find the area. So now we know the borders. The lower one is x 3 over 2 to the 4x. That means I'm going to type here for the x, sorry, for the y, is going to be just 4x here. Y equal x 3 over 2 and y equal 4x. For the x, there's going to be from 0, here is the x, from 0 to 16. So the second boundary is going to be here 16. Now we need to find the integral. So our integral is going to be from 0, 16, and from x 3 over 2 to the 4x dy dx. So it's going to be equal the integral from 0, 16. This one is going to be y from x 3 over 2 to the 4x, and the left is dx. So this one is going to be equal to the integral from 0, 16, plug in this one, so it's going to be 4x minus x 3 over 2, everything dx. Now let's do the integral with respect to the x, so it's going to be 4x squared over 2 minus x 3 over 2. We can add 1, so it's going to be 5 over 2 over 5 over 2, and everything with the border from 0 to 16. Let's simplify this one before we plug in, because this one is 2x squared minus 2 over 5 x to the 5 over 2. And from 0 to 16. Let's plug in these numbers. So plug in the 16. This one is going to be 216 squared times 2 is going to be 512. Let's check that. 16 times 16 times 2, yes, 512. So here's the first number is 512 minus 16 to the power 5 over 2 times 2 is going to be 2048. 2048. 2048 divide by 5. And now minus, this is 0 minus 0, the double bound. And this one is going to be, I'm going to multiply by 5. So times 5 is going to be 2,560 minus 2,048. It's going to be 5 to 12 over 5. This one minus 24.8. It's going to be 5 to 12 over 5. So I'm just going to type here 5 to 12 divided by 5. I hope we got it. We got it right. So let's, with example 14, let's find which one is going to be the right graph. Before I'm moving on, let's check here. The first integral is for the x. That means this both are for the x. So we have x equal 3 and x equal square root of y. Now I can't graph this one to find which one is going to be that, because x equal 3, that means 3 until here. So I can't choose this one and 3 here and the 3 here, but I need to check this curve. Maybe 3 here, maybe this one. So if you look to the second one, we can't graph this one. We have to square both sides. So x squared is going to be equal y. That means y equal x squared, which is the parabola up. So if you do simple graph here, it's a parabola, so that means it's going to be like this. This is y equal x squared. And the parabola is 1, and the 1 here is going to be 1, and 2 is going to be 4. Now, this is on the boundary, the other one with the x3. But 3 is going to be 9. So to graph the parabola, at the point 2 is going to be 4, at the point 3 is going to be 9. Let's say this is 9. That means the point here, this is what we need to graph or to find the area. So the point here is 3, 9. Which is the outside boundary for the x from 0x, for the y from 0 to 9, and for the x from 0 to 3. That means we're going to choose this one. And now we're going to write down the boundary from 0 to 9. Is that the same dy? No, dx. Yeah. The second one is the opposite thing. So the second one, we're going to find dy to the dx. So we're going to go back here. Now, what I'm going to write down here, the outside boundary, because it's going to be x. So from 0 to 3. And the inside is for the y. So it's going to be y equal x squared and y equal 0. So from 0 to the x squared. And now it's going to be dy dx. It means f to the xy dy dx. So just type here to the 3, and here is going to be x squared. That's the only thing they ask you. Here we go. Let's analyze this one, dy and dx. That means the first one is y. Y equal square root of 4 minus x squared. I'm just going to type this one. So the first one is y equal square root of 4 minus x squared. So how are we going to check this one? Y equal square root. So if you square both sides, it's going to be y squared is going to be 4 minus x squared. That means, let's check the first thing. It's from -2 to 2 for the x. From -2 to 2 for the x. And for the y, we can't take this one because this is for the y. From the outside border, from -2 to the 2 for the y. We can't take this one because the same thing is for the y. And from is if you take it for the x, from -2 to 0, and here from 0 to 2. So none of these equal to this part. What about from -2 to 2 as an outside border? So this one is the right graph, but let's check here. From 0 to 2, which is now from 0 as a y to this curve, I can take the point because we have curve here, which is half the circle, 4 minus x squared. It's half of this circle. This is the curve. This is our curve. So that's why we're going to choose this one. This means going to be half circle. But now, I think they're going to ask you the opposite thing. So now for this half of the circle is going to be, that's the only thing they ask you on the first part, just to choose the right graph. The second part, yes, this is the second part. Now, if you flip these two, because the first one we have dy dx. Now, what about if you have this one is going to be equal dx dy? This is going to be different. Our side border is going to be from 0 to 2. Like if you, here's the thing. This is for the first part. From -2 to 2. And as an outside is going to be from 0, from -2 to 2 as outside with respect to the x. And for the y is going to be from 0 to this one, because you're going to keep plugging rectangles here and keep going up the second one. So from 0 to the curve here, which is y equal 4 minus x squared. Now, if you take here the opposite thing, our border is going to be different. So we have to find here to here and keep going to this curve until from -2 to 2. So it's going to be the integral from, let's do it here because I need to keep going and find the x here. So it's going to be the integral from 0 to 2 with the dy. Alpha for the x with dy. And the second integral is going to be, now we need to solve it for the x because the x is the one inside. Dx dy. And here is f to the x, y. Solve this one for x. So move the, is going to be -x squared equal y squared minus 4. Then multiply by negative. So x squared is going to be -y squared plus 4. Take the square root. So x is going to be square root plus or minus plus and minus and the plus here. And here is going to be, I'm going to write down 4 minus y squared. So if you look to the lower bound here, the lower bound is negative 4 minus y squared. Negative square root of 4 minus y squared. And the upper bound is going to be the positive one, which is 4 minus y squared. So we're just going to type here from 0 to 2. And we're going to type here is positive. No, this is square root of 4 minus y squared. Let's check. There we go. We got it.